So we have seen in the previous classes, we have started with the second topic, second chapter, reasoning and proofs. In that we have completed with the conditional statements, the converse, the negation of a statement, the converse, the inverse, contrapositive, all of these statements we have seen. Now in the next class from today, we are going to continue with the topic and going to see about the biconditional statements. Okay. Yeah. Is the initial thing what taken, is it clear to you, Sanvi? Can I continue with this?
Yeah.
Yeah. So now we have already seen the conditional statement. Conditional statement is nothing but the if-then form of a given statement. You can write the definitions of any geometrical figures as a conditional statement. So also we have a biconditional statement. Now what is a biconditional statement? We are going to see. A biconditional statement is the statement that contains the phrase if and only if. Means the words are P if and only if Q. And if you want to say represent the biconditional statement, it is like this. Because conditional statement, we are going to represent it in this way. This is the conditional statement. P implies Q. But when we actually represent a biconditional statement, it is we have to see that the arrowhead, what is there? Okay, the arrowhead is towards both the end here, and we have P, a double arrow like this, where there are two arrowheads at both the sides, and Q. This is the representation of a biconditional statement, and you use the phrase if and only if. This is the phrase which is used in the biconditional statement. And you can write the definition of any geometrical figure or any geometrical term as a biconditional statement. Like if you take that for example, if you want to see how do we write a biconditional statement, for definition of perpendicular lines, if you take the definition of perpendicular lines to write it as a biconditional statement, how are we going to do it? For that, we first need to define what are perpendicular lines. Okay, so if the definition of a perpendicular line is if two lines intersect to form right angles, then they are perpendicular lines. You can see here in this figure, S is perpendicular to T. You can see here this particular symbol tells us that the line S is perpendicular to line T, and this is the indication of 90 degrees, right? So then this the definition we have seen. If the two lines are intersecting, this is the point of intersection, you can take it as O, and if they are intersecting at right angle, then they are perpendicular lines. This is going to be the definition. Now, how do we write this? In the first is the thing, we write it in the conditional form, P implies Q. That is, if two lines intersect to form a right angle, then they are perpendicular lines. The definition is written in if-then form. The definition is first written in if-then form, which is the conditional statement. Then you're writing this is P implies Q. Now you're writing Q implies P. That is the converse of the statement. That is, if two lines are perpendicular lines, then they intersect to form a right angle. That is, you are interchanging the hypothesis and the conclusion. Q is taking the place of P and P is taking the place of Q to write the converse. Q implies P. Now, after writing the definition, the conditional and the converse statement, we can go for the biconditional statement. As we have seen that in a biconditional statement, we need to use the phrase if and only if. Okay, so when we write the biconditional statement, we write it like this. Two lines intersect to form a right angle if and only if they are perpendicular lines. So you can see there is the use of the phrase if and only if here when we write a biconditional statement. Okay, so two lines intersect to form a right angle if and only if they are perpendicular lines. So this is what is a biconditional statement. So any type of definition can be written as a biconditional statement by using the phrase if and only if. So also we can just go for a few examples here. They are shown already. So we can see the examples how to write a particular definition or a statement in the biconditional form. So you can see, rewrite the definition of a right angle as a single biconditional statement. So the definition is not given. We need to define a right angle. First of all, we need to define a right angle. So definition, if an angle is a right angle, then its measure is 90 degrees. So definition of right angle is an angle which is equivalent to 90 degrees. So if an angle is a right angle, then its measure is 90 degrees. Now rewrite this. You have to rewrite this as an, what to say, a biconditional statement. So how will you write this? Can you tell me, Sanvi? The definition is given. If then form is given of the statement, you can write it in the biconditional form. How will you write this?
If and only if an angle is 90 degrees, then it is a right angle.
No, if and only if, that phrase should come in the middle of the statement. You're not going to begin with that phrase. Whenever we write the biconditional statement, the phrase if and only if is going to be in the mid of the statement, not at the start. So you're going to start with, if you're not going to write, you're going to write the definition, the initial part of it. An angle is a right angle if and only if it measures 90 degrees. So to write a biconditional statement, you're not going to take if, you're going to take the initial part after if. You can say the hypothesis part can be taken. Okay. So an angle is a right angle if and only if it measures 90 degrees. If and only if it measures 90 degrees. So an angle is a right angle if and only if it measures 90 degrees. Now the next one you can try. If two line segments have the same length, then they are congruent. This is the definition. How will you write it in the biconditional statement? If two line segments have the same length, then they are congruent segments. Yes,
two line segments.
Yeah.
Two line segments have the same length if and only if they are congruent segments.
Yes, exactly. So two line segments have the same length if and only if they are congruent segments. So whenever we have the definition, you can directly write the biconditional statement. It is not that we have to go for the conditional, its converse, and then go for the biconditional. You can directly write the biconditional. Only see that the phrase if and only if is going to be in the middle. You're not going to write this if there. You just take the part after if as the initial part of the statement, then put if and only if, and then take the other without taking then. That then has not to be taken. Okay. Yeah, you can just try one of this. Yeah, anyone, 12th or 13th, you can take any one of it and just tell me how will you show. Now see, if Mary is in theater class, then she will be in the fall play. If Mary is in the fall play, then she must be taking theater class. Now, if you see this statement, this is a combination of a condition and conditional and its converse. So two statements, the conditional statement and its converse are together taken as a one statement. Okay. So if Mary is in theater class, then she will be in the fall play. This is one part which can be taken as the conditional part. If Mary is in the fall play, then she must be taking theater class. So this is the conditional statement, and you can see that this is the converse of it. So it is the combination of, because we can see in the second part here, in the converse, we can see that the conclusion and the hypothesis, they are exchanged or interchanged. Okay, so P and Q. In the first part, we have P implies Q. In the second part, we have Q implies P. And that is the reason why we say that it is the converse. Now, when we have the combination of conditional and its converse, how do we write the biconditional form? You just have to consider only the first part. Because see, both are going to be one and the same. So just consider the first part of it, the conditional part of it. And from the conditional, you can go to the biconditional statement. So if you want to write the biconditional part, you go for the conditional statement, and from the conditional, you can directly write the biconditional statement. While writing the biconditional statement, you have to just, you don't have to interchange the hypothesis and the conclusion. They are going to remain on their positions. Only you have to see that if and only if comes by taking out that if then part. If then part is taken out, and in place of that, if and only if is just put in the mid of the statement. Okay. So how will you try for the first one? If Mary is in the theater class, then she will be in the fall play. You can just consider this conditional part of the statement. The converse part you are not going to consider, and write the biconditional. So how will you write it, Sanvi?
Mary is in theater class. Okay, wait. So Mary is in theater class. Then she will be in the fall. If and only if. Okay, wait, sorry. Mary.
Yeah, you're
Mary
going to.
isn't there.
Yeah, start it like that, because we don't need to write that if there.
So Mary is in theater class. If and only if she will be in the fall play.
Yeah. So Mary is in the theater class if and only if she will be in the fall play. Means all the participants who are there in the fall play will be in the theater class. That is the meaning of that particular statement when you write it in the biconditional form. So as I've told you, you are going to consider only one part of it. If you're taking the conditional part, you just keep the hypothesis and the conclusion part as the same. Only in place of if, then you have to put if and only if. Now you can go for the next one also. Just try the next one. Can you read the next one, 13th one? Rewrite the statement as a single biconditional statement. Okay, just try the 13th one.
You could run for president if and only if you are at least 35 years old.
Yeah, you can run for president if and only if you are at least 35 years old. That will be the biconditional statement, a single biconditional statement for this 13th question which is given. Okay, so that is writing a statement as a biconditional statement. So we have seen all the different types of statements, the conditional, the converse, inverse, contrapositive, and the biconditional statement. Now making the truth tables. How do we do the truth tables you're going to see? Now, if you're considering the conditional statement, so you can determine the conditions under which a conditional statement is true by using a truth table. The truth table below shows the truth values for hypothesis and the conclusion part. So when we take P implies Q, which is the conditional statement, you have to have the truth table for it. Now, when we take the truth table, you write P, Q, and P implies Q. These are the three columns for the conditional statement always. And see, when true and true, true implies true. So it is true and true. When P is true, hypothesis and the conclusion are true, P implies Q will also be true. If P is true and Q is false, okay, so P is true and Q is false. True does not imply false. So it is going to be false. Truth implies false is going to be false. So that is TF is going to be F. FT, false implies true. False implies true, it is going to be a true statement. Just keep this in mind that true implies false is going to be false, but false implies true is going to be true. False implies false going to be true. So here we can see for the conditional statement, you see that only truth implies false is going to be false. Otherwise, all are true. True implies true, truth implies true is truth. Then we have false implies true is also true. False implies false is also true. But if you're saying that true implies false is going to be false for the conditional statement. Okay. So you can see the conditional statement P implies Q is only false when a true hypothesis produces a false conclusion. So if a hypothesis that is P is true and Q is false, then the combination of this is going to be false. A true hypothesis cannot produce a false conclusion. Therefore, we say that this is the only part when we have the false of it. So for the conditional statement, okay? So there is only one thing where it is going to be false, that is true implies false. True hypothesis implies a false conclusion. That thing is only going to be false, otherwise all are going to be true. And we say that two statements are logically equivalent when they have the same truth table. Now we are going to see the truth table for the conditional, for the converse, for the inverse, and the contrapositive. And then by looking at the truth tables, we can conclude which two statements are actually the logically equivalent statements. Now, when do we say that the two statements are logically equivalent? When they have the same truth table. You have to first frame a truth table for each one of this and then see for the identical truth tables and the truth tables for which they are equivalent. The truth tables, when they are equivalent, we say that these statements are logically equivalent. Okay. So making a truth table, you have an example here. So see here, we have seen the conditional. Now we are going for the converse, the inverse, and the contrapositive. Use the truth table above to make the truth tables for the converse, inverse, and the contrapositive of a conditional statement P implies Q. So we have already seen the truth table for the conditional part. Now we are going to see the next part of it, that is the three other statements, that is the converse and all of it. Okay. So how will you actually make the truth tables? And then we can see from the truth tables which are the equivalent logically equivalent statements. So here we can see for the converse, P and Q is going to remain the same, but only Q implies P because it's a converse now. So true, it is going to be true. Q implies P, which is the converse, is going to be true. True implies false. True implies false is going to be true here. For the converse, you're going to see that the hypothesis, a true hypothesis produces a false conclusion can be a true one for the converse, not for the conditional, but for the converse. False implies true here is false. So here we can see in the converse that in the conditional, true implies false was false. But here in the converse, this was for conditional statement. Now, when we see the converse, false implies true is going to be false. So this is the difference in the conditional statement truth table and the converse. What is the difference is true implies false was false for the conditional, whereas for the converse, false implies true is going to be false. False implies false is going to be true. So you can see for the converse also, all the three things are true, but only false implies true is going to be false here. Okay, so this is a truth table for converse. Now going for inverse. Now when we take the inverse, we need to take the negation, not P inverse implies not Q. So when we take the inverse, you see the number of columns are increasing because we have to take the column for not P, not Q, and then we have to take this both. Not P implies not Q. So true, P is true, Q is true, the not P is going to be false, not Q is going to be false. P is true and Q is false, false and true. You have to just take the opposite, not P and not Q, you have to just take the opposites of this. If it is P is true, the not P will be false. If PQ is false, the not Q will be true. False true will be TF and FF will be TT. Now you have to consider only this part. For the final, this not P implies not Q, or negation of P implies negation of Q, you have to take false implies false true, false implies true. False implies true is true. True implies false. True implies false is going to be false, and true implies true is going to be true. So you can see even in this particular table, making the truth table, 3 of it are true. False, false is true, true, true is true. False implies true is going to be equal to true. And this, what is the going to be the false statement? T implies false. T implies false is going to be equal to the false statement. Okay, T implies false is going to be equal to the false statement here. And when we take the contrapositive, contrapositive is when we take the not Q implies not P. So again, we need 5 columns here. P, Q, not P, and not P implies not Q. T, T, F, F, T, F, T, F. Okay, T, T, F, F, T, F. Now here you can see T, F, it becomes not Q and not P. Then F, T becomes F, T, and F, F becomes T, T. Now we need to consider this too, to write the last column. So false implies false is true. True implies false. True implies false is going to be false. Then false implies true is going to be true. False implies true is going to be true. And true implies true is going to be true. So we have made the truth tables for the converse, the inverse, and the contrapositive. Okay. Now, when we look at the truth tables, you can see that the identical truth tables which are there, those are actually going to be the logically equivalent statements. So you can see that by looking at the two tables, which are the logically equivalent statements? Can you tell me which are the logically equivalent statements? If you can see here, now we have made the two tables for converse, inverse, converse, contrapositive of a conditional statement. By looking at this, which are the logically equivalent statements? Can you tell me?
The converse and the inverse.
Yeah, so the converse and the inverse, if you take converse and the inverse, they are going to be the logically equivalent statements. And so the converse and the inverse are because they have the same truth table. Even we can see that the conditional and the contrapositive are logically equivalent. So whenever we take the logically equivalent statements, the conditional and its contrapositive is going to be logically equivalent statement because the truth tables are identical. So also converse and inverse of a statement both have the same identical truth tables, and therefore we say that they are logically equivalent statements. So you can see that conditional is logically equivalent to contrapositive, and converse is logically equal to inverse of a this statement. So they are called as the logically equivalent statements. So this is how we have the making of a truth table. We have seen the truth table for all of the different cases. The conditional, first we have taken the conditional statement, and then we have seen the inverse, converse, and the contrapositive of it. So in the same way, you can just make the truth tables for all of this. Now